We are still looking at triangle congruence, and now we're going to look at a couple of the postulates that we can use to prove that two triangles are congruent. These two postulates are known as SSS, that stands for side, 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 and SAS, which is side, angle, side. So the SSS, side, side, side congruence postulate says if three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent. So I have a couple of triangles here. And so I want to list the congruent sides here. So I'm going to start with AB on this one. So side AB, say segment AB. And then that one has one tick mark on it, so it's going to be congruent to segment DE over here. And let's see, then one with two tick marks on it, I've got BC. It's kind of a messy C. There we go. So line segment BC is congruent to line segment EF. And then the side with three tick marks on it on the first triangle is CA. And CA is congruent to FD on this one. All right, so because I've got three pairs of congruent sides from one triangle to the other, that means that the two triangles are congruent, so I can write a triangle congruent statement here. So I'm writing a triangle to represent triangle, and then I need to list these. So I'm going to do this first one. I'm starting with the one tick mark side. So I'm going from one tick mark to two tick marks to three tick marks. And so that's the order that I'm going to list the letters in for the vertices of this triangle. So this is triangle ABC. And I need to do it in the same order on the other triangle. So I'm going to be starting on the one tick mark side, but I need to start on the side that's going to allow me to progress to the two tick marks and then to the three tick marks. So when I name this triangle, I'm going to call it DEF. Alrighty. Okay, so a little bit of vocabulary for you here. The angle that is formed by two adjacent sides of a polygon is called an included angle. So like, for example, on this triangle over here, angle ABC, so ABC, that would be this angle right here. It is formed by two adjacent sides. The sides are AB and BC. So that would be the included angle between those two sides. Now, any two triangles that are formed using the same side lengths and included angle measure are also congruent. This is our second postulate. This is the one that we call side, angle, side. Now, the order in which we state these things is actually very important. So it has to be side, angle, side, because the angle is between the two sides for this postulate. So it says if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. I have some weird spacing going on there. Sorry about that. Okay, so again, I've got two triangles here. I see that from one triangle to the other, on one side I've got a single tick mark, on the second side I've got a double tick mark, and then between those two sides, so the included angle on each one is marked with a single arc, which means those two angles are congruent. So I'm going to list these. My sides that are congruent, the one tick mark side from the first triangle is AB, and the one tick mark side on the second triangle is DE. For the angle that they have that are congruent, angles that are congruent from the first triangle would be angle ABC. And from the second triangle, it would be DEF. And then finally, the other side that they have congruent from the first triangle would be BC, and from the second triangle, it would be EF. Now, because these two triangles have two congruent sides and the included angle is also congruent, then I can say that the two triangles are congruent. And once again, I need to make sure that I name them correctly. So I'm going to start with A on this triangle. I'm going across the one tick mark side, across the included angle, across the two tick mark side, and then back. So when I name it, I'm going to name it ABC. And when I name the other triangle, I need to make sure I do it in the same order so that it is a valid congruent statement. So I'm starting with D on this one, going across the one tick mark side, around the included angle, across the two tick mark side, and then finally back to the beginning. So this triangle, I'm naming it DEF. This is using side angle side congruence postulate. We abbreviate these, by the way, using SSS for side, 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 and SAS for side, angle, side. It's standard abbreviations there. Okay, so we have a little bit of practice here. This would be a good place to pause the video and try number 1 and number 2, and then come back and see how you did. The directions say, for each pair of triangles, tell which postulates, if any, make the triangles congruent. And if the triangles cannot be proven congruent, then write cannot be determined. Okay, welcome back. So on number 1, the triangle that is congruent to triangle FGE is triangle HGE. So FGE is this way, HGE is this way. The congruence postulate that guarantees that is side, side, side. They have two sides marked as congruent on these two triangles, but for the third side, the two triangles share that side. So by the reflexive property, that side is congruent to itself. So I can say that all three sides of both triangles are congruent to one another. With the second one, we have that same sort of situation going on here. We do have a shared side between the two triangles that are given. However, the other side that we know that is congruent from one triangle to the other is not an adjacent side to the angle that is given. So this is not side angle side. This one includes two sides, but it does not include the included, or does not have the included angle listed as congruent. So for this one, it cannot be determined that these two triangles are congruent. Okay, go ahead and try 3 and 4 now. So you're going to pause the video again and see what you can do. Okay, welcome back. Again, for number 3, we cannot state that these two triangles are congruent because on one triangle they gave me a side angle side, but on the other triangle they gave me two sides and the angle that is not included. So for this one, I cannot determine it. This is not side angle side. For number 4, the two triangles are congruent. They tell me two sides are congruent, and then they don't tell me specifically that we have the included angle congruent. However, I know from my angles unit that we did just a little while ago that these two angles here are vertical angles, and therefore they are congruent. Those are the included angles. Excuse me. Those are the included angles between the two adjacent sides. So this one is congruent by side angle side. And they gave me the triangle JKL. So they went 2 tick marks and then the included angle and then 3 tick marks when they named the triangle. So when I name the other one, I need to make sure I go 2 tick marks, included angle, 3 tick marks. So NKM. Okay, for these last two, the directions change. They say, state what additional information is required in order to know that the triangles are congruent for the reason given. Okay, welcome back. On the first pair of triangles, in order to use the side, side, side congruence postulate, we would need to know also that RS, line segment RS, is congruent to line segment DQ. So the two that are on the outside here. They don't have to tell us explicitly that QS is congruent to itself because of the reflexive property. Anything is congruent to itself. For the second one, in order to use side angle side, we would also need to know that VW is congruent to VM. And they don't have to tell us that these two angles are congruent because they are vertical angles, and we know that vertical angles are congruent.